And it looks like we're live. Hey guys, this is Tully and welcome to Let's Build a JRPG Part 15. So, just like the last stream, I've done a couple things off camera. Now, not as intense, because I think the last stream, it was too much to explain at the beginning, so I just did a little bit of prep work just to give us a little bit of acceleration in this session. So, the main things that I wanted to do today, if we take a look at our backlog sheet, was in here. Actually, there's one more thing I want to say before we jump right into the code stuff. I'm curious how many people are actually interested in this stream. One thing I've had is a long time on YouTube is, or one saying or thing I've always said on YouTube is that I'm mostly doing these videos because I enjoy creating them, not necessarily because I expect people to get enjoyment out of them. But like, I enjoy making them, and if other people enjoy watching them, then that's a bonus. I've said that for many, many years. But on this series, more so than any other, because it's so niche in like the coding centricness of it all, I think it may be actually true that this might be something I'm enjoying making that there may not be a lot of people actually enjoying. So if you guys are watching this series and you've heard this, then fantastic. I am seeing that there are several likes on these videos, and I've seen a couple comments here and there, but I just want to double check and see, is anyone actually watching these? Because if not, then I can reduce the quality even further. But if you are, then that's just good to know. But I'm going to be continuing to make these either way because honestly, it's been really helping me be productive and continue to learn Unity myself. Okay, cool. That's all I want to say at the start. Now, let's dive into the code. So, the last things we were looking at was in the last stream, we did a major refactor of the character manager, which also led into getting attacking enemies working, which wasn't really less than an hour. This was actually probably one of the bigger tasks. But it kind of came almost for free, just with a little bit of finesse, from doing the character manager refactor. So this was last stream. Now this stream, the thing that I want to finish off so that we can finally start making some actual iterative experimentation processes on this is I want to try doing basically this team manager and encounter data stuff, which is going to require refactoring the combat character manager a little bit more, but really at this point we're looking at one task, which is team manager and encounter managers. So what do we do to prep for that? Well, I moved some files around, number one. Basically the ability design data, character design data, monster design data were all in separate folders, but we're getting to the point where there's enough design data that I want them all in one spot. Because I've made a zone design data and an encounter design data. These are coming from these tabs in here. We've had these kind of mocked up as an explanation tool for a while, but I've actually now got them so that we downloaded these spreadsheets as TSVs, and I've created a design data format for each of them, and I've built a parser for each one as well. So if we go into here, we can take a look at the zone parser, or let's see if I can get all these files up and running. So we've got the zone design data, we have encounter design data, we have zone parser, and we have zone parser. Okay, so we've got these two new files. Basically, the encounter data kind of comes first. It basically has an ID for this encounter, and then has a list of enemy IDs. So if we go back to the actual design data that we're importing in, we have an encounter ID, and then we have a list of monsters. So encounter 1 would be a single enemy, which is Cactus Orange, which this ID is based off of the spreadsheet in here. So this is referencing this data. So we're saying we're going to have one Cactus Orange and we're going to have two Ghost Blues. And so that should come in here as grabbing this guy and spawning two of them. And then inside of the zone data, I want to have something like forest, and then forest is made of encounter 1 and 2, and then forest 2 might be encounter 1, and we can continue to add more of these as we go. These are named ranges in this spreadsheet, just a little bit of tutorial on spreadsheets, but you can have named ranges. So in here I've said anything from A2 to 1000 is our named range, and encounter names can be 2 to 1000. And then in these cells here, we've done some data validation, which basically, data validation just says, hey, I want this to be a list of whatever this named range is. So it's going to grab the list of all of these things, and the only thing that's valid in here would be one of those. So if I just type in monster blah, then that's going to be a fail because that's not actually part of the named IDs. So this should make sure that we're getting only monsters in the encounter data that are actually inside of the monster list. We can get more elaborate validation, but that works for now. Same thing here. This is basically going to give me a drop down of all the possible encounters that we've created. So I could make a new valid encounter, which could be encounter 3. It could have 2 monsters, and we can say that that's Death Knight orange, and then we can go into zone, and we could say, hey, this cell is validated, and we want it to be encounter 3, and we want it to be 1 encounter ticket. We'll get to these tickets in a bit, but basically I'm going to use these to say how rare something is. So the lower the number, the more rare it is to show up. So that's basically zones and encounters. That's the design data we've had for a while. How's that look in code? So we've got a list of enemies. And then we've got a dictionary of encounter IDs. The first ID will be the encounter ID. The second ID, or the second value, will be the chance of picking that encounter. This is not a great way of doing this. Honestly, a class would be better, but right now, because it's only 2 values, I'm going to do it this way. Okay, then we built new parsers. Again, I went over this off camera because we've built parsers in the past. They're pretty straightforward. There's nothing too innovative here. Or at least there shouldn't be. There was a little bit on zone parser, but for the most part, we're just reading in a file and parsing in the data into these types of structures. So zone parser was the only thing that was a little unique, because normally we've been reading line by line and assuming each line is a new input for the data. But for the zones, we actually say this line is forest. And then until we find another value in element 0, then we say that this is all part of that forest data, so that I can continue to add more lines. And I could say encounter 3 has a chance of showing up in forest now, and then this would all go into forest. So I had to modify the parsing way we did parsing a little bit. Primarily that's just element 0. If it's not equal to an empty string, then we generate this as a new zone design data, setting up its ID and setting up a new list. Otherwise, if this value is 0, or even if it's empty or whether it's not empty, we're going to just add the values we find in element 1 and 2 to the list of encounter IDs. Again, not going to go too deep into that, but we're just setting up the parser to parse stuff in. Stuff I've kind of shown before, so I'm kind of skipping over it. And that's going to kind of be the new mentality, I think, is that I'm going to try and do as much as I can off camera without like repeating stuff we've done previously. This stuff is pretty repetitive, so it seemed like a good candidate for it. Okay, the other thing I realized was we had a bug called out in the general backlog that when we would go in and out of battle, the lighting would get weird sometimes. I think I was looking at this a little bit. If we go into lighting data and we take a look at the town had this data set inside of the box inside of its lighting design data. None of this was set here. This was set to like a gray value. This was not checked, and this was not checked. So I remember what these values were, right? Yes. So I think what's happening is when we switch back and forth between the forest scene and the town scene and the battle scene, because the lighting is different, for whatever reason, it's not resetting properly. So to make our lives a little bit easier and not have that weird popping of lighting, I'm going to try and fix it by just setting the lighting values of the battle scene to be the same as the lighting values of the town and the forest. Because the town and the forest look okay, so I don't want to necessarily make them look worse. Alright. Let's now fix this looking pretty awful though. So the last piece then, here, inside of lighting, this looks pretty blown out, and this was kind of the problem we were running into. I'm gonna do that just to remove some of the intensity. It looks kind of orangey, which I'm not super fond of. Honestly, that probably has to do something with the color. No, everything we chose is white. Huh, I must just be this ambient color being slightly orange is just amplifying it. For now, I'm going to leave it. It doesn't look great. I mean, it didn't look great before, so I'm not too concerned. I also kind of replaced the Final Fantasy with just a white background with the text loading image or loading. So yeah, this is now working okay. These guys are attacking us. We can attack back. Death is still not working on the heroes. We need to get to that at some point. Last thing I'll mention that I did off camera though was in order to get these next steps working, I really needed to do some stuff with the global scene. So we used to just have the transition manager. The big thing we're trying to move towards is inside of the character loading manager now. We load up the characters and the monsters just based off the design data. We just grab the list of data and we load them in. Instead, we want to have a team data and we want to have an encounter data that loads in this information. In order for this to work, it needs to live somewhere. So I've created a backend manager and I've stubbed in 2 empty classes. So the backend manager is going to have a reference to a team manager and an encounter manager. These things will be used to populate the character loader when we load into a battle. In order for that to work though, I realized that the data that we load in kind of needs to be loaded up all the time globally. So this data here used to be loaded inside of this manager, which used to just be called loading manager. It used to handle loading the data, but that meant we only loaded up our design data when we actually got to it would only load up the design data when we actually went into a battle scene. But now we're going to need the team data to always be loaded the entire time. So I basically just broke out the battle load manager's data loading into its own class, which I called data loading manager. Just going to rename the object to match. And now this thing is handling creating the character design data, ability, monster, encounter, and zone design datas, all the design datas. And we're going to use those now as part of the setup. Looks like we might have some buffering issues on Twitch. Interesting. Try just refreshing the page and see if it's just me. How long did that take? We're going for about 15 minutes. It took me 15 minutes to explain all of what I did off camera. Okay. So, moving right along. Next steps. We got everything set up now. We have all the design data coming in. Really, it's working from the character loading manager. This data here shouldn't be coming in here directly. Something should be handing this off. Let's start with the characters. Okay, we're going to slow things down. Now that I'm done rambling very quickly, we're going to take a breath, we're going to breathe, and we're going to just execute on making some of this stuff work. So we're going to need to have a team manager. For the sake of the backend manager, I've made it a singleton, but the team manager and the encounter manager are just mono behaviors that are being referenced by the backend manager. I want the backend manager to handle a lot of stuff, and rather than have a bunch of singletons for every single possible thing that the backend manager would do, instead I want there to be just one manager handling all of this. And it will be in charge of, if you need to get team members, you go through the backend manager. It's just trying to consolidate some of the singletons into one reference point. So I think we're going to need another class, which is going to be a team member. And that team member is going to have a reference to the stats class, which is the primary thing that I think I want to persist between battles. What has been our naming convention again? We're doing M underscore in this project. Okay. So we want stats to persist between combats. We want to keep levels. We want to keep upgrades, anything like that. So if for now, let's start with just that. So this team manager is basically going to need to grab the existing logic we have for loading characters. Yes. It's going to want to grab the character design data, and it's going to want to load up all the characters. Let's start with that. Now this is going to require us to wait until the design data has been created, though. Why are you complaining? There we go. Oh, it doesn't like that I have the yield new in here. How does this handle it? So this is technically a coroutine. I don't actually need all of this logic. What I really need is just a unit. I don't even think I need mana or health or damage effect listeners or any of this stuff. I think I just need to add a stats component to something, and I need to retain that stats component. So I don't think I need to do it exactly this way. I think what I need to do is I need to have a list of team members. Is equal to new team members. And then from here, we are still going to want to grab the design data. Just stealing code from different areas. We want to wait until data is done loading, so we'll do that for this coroutine. So this coroutine is going to wait until the data is loaded, and then once the data is loaded, then we're going to loop through all of the characters in the design data. And for the time being, I think we'll just generate all the characters. We'll not worry about like picking team members, because like in true fashion, we should have it so that like there's maybe like key characters that exist at certain story points, and we might want the team members to always exist, but which team members are currently active in your party might be a setting that we'll want at some point. For now, we're not going to worry about that. We're just going to try and parse out the whole team system and put it directly into this manager so that it's not being loaded directly, and then we can kind of do more stuff as we go. So this character model, we use this to initialize it passing in this design data. And that design data gets passed through, and that design data is used on unit factory create unit, and then that design data is used inside of the stats object. And right now the only thing we pass in is initiative. Right, okay, so this is the other big task that we have to kind of work on today, is this whole idea that we are only passing in initiative. We really want to do importing stats from design data. So we might want to try and tackle that as part of this. Okay, so we get all these design datas, and then for each of these character design datas, right now the only value that we care about is initiative. So get this working first, and then we can worry about adding more design data later. So the only thing we care about from stats is initiative, which gets passed down to the unit factory. And then we set all this stuff up by default. So we want this function duplicated in here. Okay. All right. And then we're going to want to create a new object. Now, how do we do that in Unity again? Game object. Game object. Let's say unit is equal to new game object. I don't think that's quite right. I think I want to initialize this. Let's just try this and see what happens. So if we just make a new game object and we set that game object's parent, I think it's transform.set parent to this transform. So this should just parent the children underneath of this object so we can see it in Unity to see if this is working. And then we set that unit game object to have a stats component. So this unit will get passed into this function. This function will then add a stats object to it and then apply all of these stats to that unit. Okay, cool. Then we add maybe this function returns stats, and we also want to create a team member. Every time we loop through, we're making a new team member essentially. So we make a new team member, and then that team member dot stats is equal to whatever add stats returns. And so then this just needs to return S. Okay. Cool. We're not using index in this situation. That's a copy and paste issue. Okay, and then we just need to make sure that we add this to the list of team members. Add team member to team members. Cool. This shouldn't do anything, but we should be able to run the project and see that in the global data under backend manager, we should have a character initialized with the basic stats for each one. Let's give this a run. We're not battling, we are looking. So there's several new game objects, each which have stats attached to them. And then if we look under debug, it should show us the variables. I honestly don't remember which one is initiative, but there should be slightly different values set. Oh, element 12, 15, 13, 18, 18. And if we take a look at our design data, 15, 13, 18, 18. Okay, so that's the speed value at element 12. And it is getting set. Okay, so we've basically initialized a list of team members. So now the backend manager should be able to write a function which is something like get all team members, and this should return a list of team members. Just fixing some indentation. Cool. Now on the character loading side, we normally loop through all of the design data. Now instead, we're going to do backend manager.instance.get all team members, which is going to return a list of all team members. So this now needs to be team member, lowercase team member for the variable. We pass that into here. So this character model now needs to initialize with team member data instead. And this is where we're going to start running into some fun issues, but now we're just working through the problems. So now anywhere it gives an error, that means that this is data that we'd likely want to come from the teams. Potentially. I think this can now pass in a stats. And then this can be basically copying all of the stats from the team members into the new stats module that we're creating, or new stats component. Sweet. Now we could directly copy or use the stats, but the reason I'm doing all of this copy and paste type stuff is mostly to try and get everything, like, I don't want any direct references to the ones in the team members, so if something happens inside of the battle that reduces the character's attack, I don't want that to reflect backwards to like the main team. I want it to kind of isolate the data, so I'm going to copy all the values over. Okay, so that should handle the stats, but we kind of have problems with the name, the ID, some other data. How can we solve that? Well, some of this stuff might not change. Like the name shouldn't actually change. So if the team member actually had a reference to its name, that would solve this. So we might want to have a public int ID, which is the character ID. And that team member dot ID, character ID, is equal to the character design data ID. Now, by doing that, that now means that we have a reference inside of the unit factory in which we could get that information, or some of this information. So how do we fetch design data in this way? How do we fetch design data in this way? If I want to get a value out of our data storage, what can I do with this? This is all character design data, and it is in a dictionary. Was I smart enough to build this dictionary? When we add things to this, we add it based off the character ID. Fantastic. So what all of that means is that we can just do this line inside of unit factory. When we create a character, a unit, we use the team member data, and we can now do, actually, I think we just want to do directly here. We want to pass in the ID into the data, the character ID. And now instead of giving back a character design data, it will give back a character, instead of giving a character design data holder, it'll give a character design data. It is complaining. That's because I think we need to do from the data the character design data. Okay, now with this, now we can get the name, the ID. I guess technically I kind of like doing character ID here. Name, abilities, and abilities. I messed up on one of those copy and pastes. Fixed. Okay. Now we did break monsters because we changed what stats takes. Instead of taking in the initiative, it takes a stats object. It's fine. And so this feels like, in some ways, didn't we just move a whole bunch of stuff around and it feels a little weird, but it's primarily to get the stats separate. So now stats aren't going to be reloaded every single time we go into a battle. The stats will always be based off of the team member stats. We will need to find a way to update stats like gaining experience after we finish a battle. But that's another step. There will be ways of increasing your stats as we progress. In fact, we have a victory condition, right? Okay, first off, there's a bunch of files that are unsaved. So let's just save everything and check to make sure we don't have any errors with that logic we've written before we go changing more stuff. Because we do have errors. Okay, it doesn't like that we don't have the character prefab anymore. But in the same way that we wrote stuff in the unit factory, we should be able to do the same thing here. So we should be able to grab based off of the team's the team character ID. The team member data has the character ID, which gets us the character design data, which can let us then spawn the correct prefab. Good. And then I think the other error is going to be around that monster spawn thing. And so for this, I mean, I just don't care. We can just pass in No, that's probably not going to work. That's probably going to complain. It's definitely going to need stats objects. This is going to break everything. We have to fix the monsters. Okay, so we basically got to the point where I want to test this, though. I'm going to grab the old stats function, and I'm just going to copy it back in. So that was in Unit Factory. I'm taking a look at the difference between the two files. Let's bring up the difference. That's not coming up on camera, but that's fine. I'm just going to grab this. Okay. And this can be add monster stats. And this is just temporary while we get everything working. At least I think it'll be temporary. We'll find out. So then this is taking in that, and then this comes in with speed. Cool. There's now two add stats functions. There's add stats for the character and then add monster stats. So now if we go back into Unity, we should have no errors. We are going to have a small race condition, which means we have two things waiting on the character data to be loaded. We have the models in the scene, and we have the team data. And something did not make it. So it's likely that before we finish loading in the team, we try and... okay. Character loading manager. This waits for the design data to be loaded, and then it initializes, which comes in here and calls the init coroutine, which calls the init coroutine of the character modeler, which then gets the team members. But the problem is that the team manager is also waiting for this. And what looks to be happening is the character loading manager gets hit first, its function gets hit, and it sees that we have no team members, and then this guy gets hit and it sets up the team. Slight hack. Wait until the count is not equal 0. Then we can continue. Now, we don't need this anymore, right? No, this can go away. Now we should be able to load into the game. People load in again. Okay, so this means that the stats for these characters is now coming from these objects. So we can test around this, which is a bit clunky, but we can do, to validate that the stats are coming in and persisting between battles, we can add a simple increase on one of the stats. And the most obvious one is max health, because we can see that on the UI, so we can see that change. So before we transition out, if the battle is over, and it will need way more complicated logic than this, but for the time being, we can get all team members. And then for each team member, in all team members, team member dot stats, stat types dot max HP value is plus equal 1. So after we finish a battle, increase the stats of all team members by plus equal 1. And remember, this is not the stats of the units that we're using in the battle, but this is the stats of the team members, which is held inside of the backend manager. Okay. Now we have to win a battle, which is the part that is more tedious. Especially because some of the death stuff isn't working on the heroes, so it's hard to tell what's happening. We need to kill the ghost still. Also, some of the enemies still attack even though they're dead. Like, there's just some weird stuff happening here, which I think I have figured out how I want to handle. So we could try and tackle that after. We resolve some of these problems. Sorry, not if we... Sorry, we can resolve some of those problems after we figure out whether or not this fighting stuff is working. Okay, so we got out of a battle. If we go into... Well, we're back in. 42, huh? Interesting. Well, it changed. We call transition between scenes 42 times then. Well, no, we start at 5. So we call it 37 times we get into this function. So we should probably just add a simple bool in here. Again, we need more complicated, like, win the match logic at some point, but for the time being, I'm just going to add a transition started, which will equal false. And then in here, it gets set to true. And we only do the transition if we have not started the transition. Cool. And this will get defaulted back to false every time because we recreate the victory manager every time we come into the scene. So every time this gets created, it'll be false. And we don't need to reset it back to false until the next time we come back into the scene. So we don't have to worry about resetting this. That's the point of that statement. Let's see if we can fix the death thing real quick. I know what the problem is. Now the question is, do I know how to find the spot where it's breaking? It's because when we go to... It's in one of the states. Which state is it though? Wait for character UI. Nope, it's not going to be this one. Is it ATB related? Is ready. If a character is ready, they'll perform an attack. So for ready and current ATB does not equal null, perform action. Check if any character is ready. So really in here, we could just say get component what is it called? Knocked out status effect. This should be null. Basically, if we don't have a knocked out status effect, then we can be ready. Otherwise, if this is something other than null, then we're not ready. So we must be ready, and we must not have a knocked out status effect. Don't know if that's the way I'll keep that logic, but for the time being, that should work. I mean, in reality, we'll probably need, like, is not stopped, is not petrified. Like, there's a bunch of different status effects. So maybe it's something more generic, like we check all status effects and see if any status effects are stopping us from performing an action. Something still broke. Let's just hold and see. Okay, that was us attacking them. So our health should go up by 1 now because we added that transition bool. Sorry, I'm bouncing around. Yeah, so we finished the battle. We didn't call the +1 max HP a billion times. So let's kill the ghost. I'd also like to fix the heroes. Like right now, what I just fixed with that death state thing, knocked out state thing, was mostly around just making it so the enemies don't attack when they're dead. Let's see if that's maintaining. No, we didn't fix that. Somewhere they're still performing an attack even though they have the death state. The knocked out state. It's possible it's because they already had an action queued. Like even after they had queued up an action. Because the way we do queuing, we just add it to the sequence. So the sequence would also need to know. So that I think the is ready, making sure that they're not knocked out, is going to stop them from ever performing another sequence attack. But if they already have a sequence in the queue, it's still going to perform it even though they're dead. Interesting. So I think here, when we go to get the first and remove first in the sequence, we actually want to check to make sure the attacker isn't dead. So how do we do that? Well, I guess this thing finds the attacker, right? So how does this thing... Current sequence. How does it use the attacker? This is a unit or character ID. I think it might be a character ID. And we use the combat character manager to get it. So I think we want to do the same thing here. Except instead of getting the unit, we want to get, or the unit animator, we want to get the unit from the result attacker, and then we want to get component. Again, there needs to be a cleaner way to do this than just getting component anywhere we need this. We'll have to write a function inside of like somewhere. Maybe it's a better as an event, like, hey, I'm going to send out this attacker as an event, and then that attacker will say whether or not the knocked out status effect could listen and say, hey, FYI, I'm dead. That might be a better way of doing this. Is via the event system. Okay, so if combat character manager get unit dot get knocked out stats effect does not equal null, that means this attacker has been knocked out. If the attacker has been knocked out, then we want to set result equal null, I think. Now, what would happen if we return null? It's just going to update again. So I don't think I need to like, I could loop through again and check the next one in the list, but I don't think I need to. I think we basically do all of this work, we remove it from the list, we get rid of this ability, but then after we've removed that ability from the list of abilities, we check to see if the attacker has been knocked out, and if the attacker has been knocked out, we return null. There is another case here, which is what happens if the target or targets, what if there are no targets left alive? And I'm not going to fix that right now. That's a much bigger problem. But to do check if targets are dead, and if all targets are dead, and if any, I guess in this case we'd want to try and find a new valid target, is really what we want to do here. Because in like an old school Final Fantasy game, if I attack the first enemy and it dies from a different sequence of events happening, like it self-destructs or someone else hits it and kills it first, then my attack still goes through, it just performs on a different enemy. I think that's the logic I want. So I'm just going to add that also to the backlog. Handle targets dying before sequence is complete. It's kind of medium. Okay, so then we've gone on a tangent. This is not where we started, and this is not where we were trying to go. We got distracted by the characters being messed up when they die. But that was not the point of this stream. The point of this stream was to get the character, or the team manager and the encounter manager working. And we got distracted here because we were mostly trying to see if we could fix the enemies attacking when they were dead. And we have still not fixed that. Interesting. Super curious why that's still broken. I know that we've deviated, and I know that there was other things I wanted to try and do, but now I'm just curious of why this is broken. Let's attach the debugger, and let's take a look at the code and see what's happening. We've kind of proven that the team stuff works, so this is kind of an okay point to deviate and try and fix this other bug. I want to get to the encounter stuff before the end of this stream though, but I think that we've kind of got the team manager working, at least in its most rudimentary state. We're able to hold stats and modify stats as we progress through the experience. We'll need to add a lot more logic to how those stats get modified and progress, but there's enough here that we can now move on to the encounter data stuff. But before that, we're going to fix this death attacking bug. If Unity decides to load... Are you hitting a breakpoint? What is happening? Okay. I'm trying to run the game and then attach the debugger. Maybe? We're not hitting any breakpoints. Everything is running. Okay. Hard stop. I guess I can't debug this. Not sure why that's broken. Okay, attack the Death Knight. Interesting. Let's add some more debug logs. Because I think that's going to be our best bet. So when does this get called? Current active unit is ready for action. Debug.log unit display name, and let's say is ready. I think part of me is a little concerned that I can't tell what's happening just by watching the gameplay, that I have to add debug logs to see who's attacking who and where is kind of problematic. But I think that's, again, our selection method of showing who's attacking where is partly like highlighting the model, and the model is dead and it shouldn't be attacking. And so that's part of the reason it's causing confusion. So it's debatable whether or not it's a real problem. But as we actually progress into actually balancing this thing, which we're still a little ways off from, but when we get there, we'll need to see whether or not this is a real issue. Let's see here. We want to do M attacker. Actually, we want to get unit M attacker, because attacker is just going to be a random ID index of some integer, which won't tell us anything. But if we get the unit, we can get the display name. Attacking. Right now, I think we only attack the first target. We don't have any multi-attack skills, so this should be a fine way to debug. I don't think we care about the ability. I was going to write in which ability, but I don't think it matters. I think we just want to know who's attacking who whenever a sequence gets pulled. And then we do want to know if we successfully remove something from the queue because the attacker is dead. Okay, so now we have a little bit more logging in here. I also should get rid of some of the warnings right now. It's complaining about there not being a relaxed state for the enemies. I'm not sure how I'm going to resolve that quite yet. But it's also clogging up the view. Ghost is attacking Archer. Barbarian is ready. Barbarian attacks Death Knight. Okay, Archer is ready. So what do we got here? So we had the Barbarian attack the Death Knight. The Death Knight process its death animation. So then we can attack the Ghost. Death Knight is ready. Death Knight is ready. Death Knight is attacking the Wizard. Okay, so it wasn't queued up. We had Death Knight is ready. Death Knight is ready. Death Knight is attacking the Wizard. Does the Death Knight not have the knocked out effect? Interesting. Oh, the knocked out status effect is not on the same level as status effects go one level lower, like abilities go one level lower. Okay, so we need to get component in children. That's the missing piece of my logic. This is kind of correct. It's still not a great way to write this code, but that was the problem. Okay. It's been a little while since I've looked at the status effect stuff, so I had forgotten that that's how status effects get generated under unit objects. So a lack of understanding of how the hierarchy of the components is being created was the problem. So now if we attack the Death Knight, interesting. Still some weird bugs. But I don't think there was the same no one attacking. So if we attack the Death Knight here, Death Knight dies. Death Knight should be the next to make an attack. Yeah, after the Death Knight dies, he never processes again. Interesting. Okay. Cool. That's part of it fixed. We still have to fix the hero side of it, but that was the thing that was causing me a bit of an issue. Let's do the encounter manager, which was the other big thing I wanted to do today. Now that we kind of got past that. So we did the team manager, kind of the easier of the two a little bit. We've basically just rerouted some data generation to be here instead of inside of the character loader. But the encounter manager is going to need to be a little different. We have two new pieces of data that we want to work with. We want to have the zone design data and we want to have the encounter design data. I think this is also going to come into play a little bit with the hacky script we wrote into the forest. So let's head over there. So we have in here somewhere a script, not transition to town, random battle temp. So right now this thing after X amount of time goes into transition to combat scene. I think before transitioning to combat scene, we want to do backend manager.instance generate random encounter, which isn't a function yet. And then we're going to want to have on this thing a string for now, which is the zone name, which we'll do as a written string. And then we'll have to make sure that this matches what's in the Excel document. So we'll say that, hey, this is zone forest. And so forest will be what gets passed in here. So now in backend manager, we're going to need to add a new class, which will be public. Oh, nope. Public void generate random encounter. And this will take in a string, which is zone name. And then don't know why it's complaining about that now. It's a serializable field, so we set it regardless of it. Never, anyway, whatever. I guess I can make it private, and that's what it's complaining about. That way it's more defined. Visual Studio is being silly. I'm going to leave it alone. Okay, so we generate a random encounter given a zone name. So given a random encounter, given a zone name, we're going to want to get the zone design data holder dot instance. No, how do we normally do this? We just did this. Problem is I'm copying and pasting so much, it's hard to keep track. This is how we do it. We do it by doing this into here. This gets us the holder, and then the holder will have the design data. And then we want to get this based off of this ID. I was going to add some error checking, but I don't think I'm going to worry about it. How do we hash again? How do we turn strings into values? It should be inside one of the parsers. What is the function? It's something to do with animation. Animator string to hash. That's what I've been hackily using. So we'll turn the string name that we get in to a hash value, which is a unique integer based off of that string. And then this should get us the design data for this zone. So we can do zone design data. So design data is equal to this nonsense. Now that we have this, this should have a list of encounter IDs. So we're going to want to pick a random one. So integer random index is equal to random dot range 0 to encounters dot count. This should be exclusive on the end. Yep. Okay. So this will work. So this will get a random index, and then we want to do sorry, I just realized I probably want to be doing all of this logic in here. Like the backend manager could handle all of this stuff. I just like separating it all out because it's going to look way cleaner. So this class is just dealing with referencing all of these, like encounter manager, team manager. The backend is going to handle a bunch of different managers, but the managers should handle their own logic. This is just some weird precision stuff. So it's just going to pass it forward. Okay. Okay, so now we have parsed through we've gotten a random index from here. We are now going to set that data here. So the encounter design data will be equal to encounter IDs, random index. We're going to do the same thing here. But instead of for zone, this is going to be encounter design data holder. Okay. This thing. All right. So basically we're grabbing the zone design data, given the zone name that will be passed into here. We then, based off that zone, get a random value between a random index in the list of encounter IDs. So that's basically going to be grabbing this one, or this one. It'll pick one of three, or if there's only two, it'll be one or two. It'll pick one of these values. And once it picks one of those values, it's then going to use the index, the ID at that value, to get the encounter design data based off that ID. And we're going to store that here. Then we're going to write a new function. I'll make this private. And we'll have a encounter design data get current encounter. And this will return the encounter design data. So this thing generates that, and then we're going to write a similar function here. Again, we're mostly just wrapping functionality that could be inside of Backend Manager inside of this encounter manager. So it just looks like it's calling the same named functions over and over, but it just makes this code look a little bit cleaner in the long run. Encounter design data. Okay. Return. Cool, cool. Now that we have all of that set up, when we get into a random battle It'll generate based off the zone. It'll create one. And then when we get to here, not here. Not here either. Character loading manager. Here. Normally we grab the monster design data and we just load those monsters. In this situation, instead, we are going to get the backend manager instance dot get current design data, or get current encounter data. Encounter design data. And we are going to use that design data to determine which monsters to spawn. So for each enemy ID, we are going to loop through all the IDs. Monster ID. And then for this ID, we are going to grab the monster design data holder, this object, and we are going to get the monster design data, and we are going to pass in whatever this ID is. This will be the monster that we want to spawn. Semicolon. Cool. Now, that should just work, right? I think that'll just work. The only gotcha that I need to be aware of is if we run the scene directly. So if we're not running from a zone, if we get into the battle by just running the scene directly, we're going to run into a problem, because this value is going to be null. So if this value equals null, because we came in here from the battle scene, not from the forest, so that there was never anything set, we should instead generate a random encounter. And then we can just for now default it to forest hard-coded. We may eventually want to add some sort of like default value so that we can load up whichever one we want. Actually, let's do that. This is inside of here, so let's just add a default zone name. And we'll make this a public value. And by default, it will be forest. Is it forest 1 or forest? What do we call it? We just call it forest. Okay. So if we load up the scene and there isn't any encounter data created yet, then we'll just create a random encounter based off of the default zone name that we can change inside of the battle scene. And then we'll grab that new encounter after we generate it. Cool. That just solves one of the potential bugs. That's all. This is fine. This all needs to be here. So now we're most of the way there. The one thing is we're not taking into account the encounter chance. So right now all values are equal. We're just getting a random index and choosing one. Value not found. Something was not found inside of something else. see, says the blind man. So that's yeah. I see. Oh, okay, I'm being dumb. So this is the thing I was just talking about. We're not taking into account the dictionary. So for testing purposes, I'm writing this in a stupid way. And writing it in a stupid way has now come back to bite me as I try and prototype it. Does this mean I have to write it perfectly or the way that I want to work it eventually in order to get even a small facsimile up and running? It doesn't like that. Dictionaries do not like you grabbing the keys like a list. Still a key value pair. Okay, right. Let's write some slightly more complicated code. Let's go through all the encounter IDs. For each encounter ID, let's run through the keys. Actually, let's do a for each value pair. This is the way I want to do this. So this is a dictionary. So the way we loop through this is by key value pairs of integer, integer. And this will be a key value pair. And then for the first key value pair, we will say that the key will be the ID. And the value so this is kind of like a lottery. This is the way I like doing a lot of random stuff. The value of this key value pair, if we remember the encounter is a dictionary, the first value is the integer ID of the encounter ID. So it's a stringified or like an integerized version of this string. So we convert encounter 1 into some unique number that represents encounter 1. The second value is what I call tickets. So we have encounter tickets 5, 5, 1. I don't think I re-imported some of this data, but the value is the number of tickets this one has. So we add up the total number of tickets, and then we do a random range based on that total number of tickets. Then we loop back through here again, and we check to see if total tickets is less than this value. And if it is, then we break and we set the key value pair key chosen to be the chosen encounter. Else we minus the total number of tickets by the number of tickets for this key value pair. And this should work. So the logic here is basically, if we have, let's take a look at an example. Let's say we take this example because it's slightly more complicated and it helps explain this a little better. So we have 5, 5, and 1. If we add all of these up, they sum up to 11. So we add all of these together, we get 11. And then we choose a random number between 0 and 11. Technically it's exclusive, so I might need to change something real quick, but let's work this out. So it's 11 and a random number between 0 and 11, so it will be something like, let's say 8. Well, let's say it's 8. So if it's 8, we'll check to see if 5 is less than 8. That's what that logic was doing. If total tickets is less than, sorry, if random index, so this is the random value, we check to see if that random number between 0 and the total number of tickets, which in our case was 11, and we're saying it's 8. So if this value for the first one is 5, then 8 is not less than 5. So we minus the total number of tickets here. Again, this bugs. We minus the random value by the key value here, which is going to be 5. So we minus this. This number is not less than this number, so we minus this number from 8. So we're left with 3. The next time we come up, we'll end up with this number. This is less than this, so we pick this as our value here, choosing this as our chosen encounter, and we go fight it. So then my question is, the way that this random range works is inclusive and exclusive for max. It won't ever do the final number. It'll pick, with integers, it'll do 0 to the one less than the maximum number. So if this is 11, it'll never pick 11. It'll pick 0 through 10. It's to do with counts and arrays and stuff. But if we chose the number 10 then, because that's the max value we would get, then we would check if 5 is less than 10, it wouldn't be, and then we do 5, and then we're doing less than not equal to, right? Yeah, so then we say 5 is less than 5, no, and we do 0, and 0 is less than 1, so then we would choose encounter 3. So I think this logic will work. I think worst case, we'll always just choose the last encounter. There might be a bug with this, but I'm not going to spend all day thinking about it. Let's just run it. Recompiling. Okay. And now if we get into combat, we're still hitting bugs. That's because we didn't save. Helps if we save all our changes. Okay. Now we should have random encounters up and running. So each time we get into an encounter, it should be a random one from forest. Nope, still broken. Why? The given key was not present. Well, really? Come on. Debug.log What is the ID that we're picking? Because if it's 0, then there's a bug and I'm actually going to have to think about this. But I was hoping it would just work. If it's not 0 and it's still breaking, then there's something more fundamentally flawed with my logic. Just quickly going to read this over. That's part of the problem. We should be adding up the total number of values. Random value is less than this value. We choose this and we break. Otherwise, we minus the random value by this. Okay. This is problematic. So even though there was a bug in my logic, it is still saying that there is a random encounter coming out. It's just saying that random encounter isn't inside of this encounter design data. And because of the way randomness works, it's alternating back and forth. So there isn't a value of -12188984664. If we take a look inside of the actual design data, encounter design data, pretty sure those are valid numbers. Yeah, that number is that number. These are valid numbers. Interesting. So then why would it be complaining unless the data isn't loaded in yet? We load the zone design data into the zone design data holder. We load the encounter data into the encounter holder, monster into monster ability, ability, a character into character. We wait until all of them are done loading before we say is loading is complete. I can't imagine that it's taking us the entire time before this happens. It is finding the right one then, so it's getting into forest and it's generating between the two values that are currently in forest. Because we haven't re-imported the design data. The design data that's in the spreadsheet is slightly off from what's here. Okay. So then the question really is what's going on with this? Let's see if we can get the debugger working this time. Wasn't working a moment ago. If it can't, I can add in more debug logs. Also, hi to Heynasar on YouTube. Hello to you. It's been a quiet stream. It's nice to hear a friendly voice. Or at least a friendly hi in the void that is me streaming and finding lots of bugs. Well, it's unfair. I mean, to be perfectly blunt, I haven't had that many issues really. It's been pretty fine. Most of our bugs today were mostly dealing with bugs from previous streams. Oh, breakpoints are working again. This has no data in it. Well, that would be a problem now, wouldn't it? So we have no encounter design data. But we did have zone design data. This data came in fine. Okay, so then somehow I messed up this loading. Yeah, because there's monster design data. That holds 3. There's zone design data. That holds 2. But there is no encounter design data. Oh, is this encounters? Is that what I did wrong? I bet you I did that wrong. I believe this is using the addressable system, so we'll have to stop. Oh, we got to stop the debugger, and then we can stop Unity. So I'm guessing it's failing to find this. Addressable encounter design data. I don't think there's any difference in that naming. Initialize, get text object, deserialize text object into the holder. Is it possible I wrote... This deserializes... Let's take a look at the encounter parser. Because the parser parses the data into the correct format. It's possible I parse it out to the wrong format. Serialize object encounter design data. This is an encounter design data holder, and we serialize it out to the encounter design data JSON, passing out that object. And if we look at the JSON object, monster design data. Is this the problem? Is the problem that it says monster design data? I bet you that's it. I bet you I renamed this to encounter design data and we haven't reparsed since then. That's a silly mistake. So if we reparse encounter design data, now it says encounter design data, which is a variable the serializer would be expecting. I had renamed a value and yeah, that was yeah. All we have to do is re-import. Silly bug. Okay, we got 2 ghosts. So if we run it again, eventually we should see a orange cactus, I believe. If this thing is truly random, I think I equally, well, so I equally weighted them. We took a look at the TSVs. Seem to be getting ghosts a lot. That is either one of 2 things, either improbable odds or something about my randomization is broken. Interesting. We were seeing it go back and forth between the 2 when it was broken. Oh, also interesting. It looks like we keep alternating or keep calling generate random encounter multiple times before we actually transition. So we got 77, which was that one. Okay. Is this the same output every time? 1, 1, 2, 2. Oh, we got a cactus man. Interesting. Okay, so it must have just been bad random chance that we got the same one over and over again. The lighting is still busted. I thought I might have solved that, but I clearly haven't. I don't want to call this over and over again. I think I want to add the same transition call that we added going out to the forest. Okay, ghosts. Cool. That was the temp class, right? That was the temp random battles. Is transition started equals false equal true. Cool. And I do believe that is now working as intended. Yeah, we really need to get in the attack a different target if that target is dead. We also need to turn off targeting the same target. Oh, interesting. This is a bug because we've spawned two of the same enemy. We use the name of the enemy or the character as the ID. So, because of that, when we attack Ghost, it attacks the first ghost in the list. But the first ghost in the list is dead, so it fails. But regardless, for targeting purposes, we shouldn't have them share the same ID. That can cause weird problems because maybe I want to attack the bottom one, but it's always going to attack the top one because it's first. So even if this whole attacking the dead one wasn't working because we fixed targeting, we would still have issues here. So instead of using the name of the character, when we initialize enemies, we should probably give them new unique identifiers. So when we do, what would that be? Unit factory? When we create monsters, we wouldn't want to use the data ID. We would want to use a data ID plus its index. Yeah. Would our system just work if we did that? Because we just use ID. Yeah, I think everything just populates off of this unit factory. Cool. It's complaining because I didn't hit save on all the files. So this means that the ID for each enemy is going to be based off the index of which it was spawned. So if it was the first enemy, it'll be 0. If it was the second, it'll be 1 because code. But it would, now they're all just, their index in the array is their ID. So if we get into a ghost battle, we should be able to hit both ghosts now. If we get into a ghost battle. Try attacking the bottom one. Try attacking that one. That hit that one. Good. And that hit that one. Sweet. So we are now getting into random encounters. Now, we can start to test a little bit of our design data stuff. So we already kind of made some modifications here. Let's make some more. So let's make cactus, ghost, Death Knight. Let's make encounter 5 be 2 of these, and it'll be cactus and Death Knight. Okay, now if we go to zone and we increase insert below, we can now add encounter 4 and encounter 5. We can make this one 3 and this one 7. Cool. And now we should be able to download TSV, save that as the zone data, save over, and then we should be able to do the same thing for the new encounter list. Encounters, save, replace. Then we just run into Unity. We go to our tools, we parse in the encounter data, we parse in the zone data, and then when we run this, we should have 5 different random encounters that we can run into. And if we switch to Forest 2, we should only have 2 encounters that we run into. That's something worth checking too to make sure that actually works as intended. Okay, we get the ghosts. This is where a reload would be pretty useful as well. If we just had a button that was just like, give me another random encounter, and we could just keep loading over and over. Oh, hit the mic. Loading over and over again. Talking with my hands too wildly. Which ghost are you? Are you this ghost? I think the names they appear in is in the inverse order they appear on the screen. Nope. There we go. Yep, different one. And this is different from any of the versions we had before, so this is a successful import. Okay. So then the next thing I'd like to try is changing the string for this area to be Forest 2, and then we should only see 2 encounters now. What were those 2 encounters? Those 2 encounters were encounter 1 and encounter 3, which should be either a cactus or 2 Death Knights. And that's a cactus. Let's just do a couple fights to double check, but I believe our encounter manager system and team manager is up and operational. There's still a lot of stuff I'd like to do with the team manager. I mean, there's equipment, abilities, magic, like stat increases on leveling up, keeping HP between battles. Like there's a bunch of different things that we need to do. But at a basic level, we now have a random encounter generator, and we have something that keeps track of the team's stats between battles. And that's a really great stepping point. So these battles are not just generated based off of our design data, but they're generated based off of some mechanics inside of the game. Sweet. I think that's going to be a good spot to call it today. And I think this is where we're going to go. One thing I'm just curious on is, and I'm going to echo myself, but I'm going to do it. Have I been on this whole time? We're going to go. Okay, yeah. Sorry for the feedback. You probably heard me talking in the video, but I went on mute because I never actually verified for 2 hours now that I actually was on. So we're good. Let's quickly, before we end the video, take a look at our backlog. So what did we do? We finished up. This is still in progress. I would really like it if the characters actually didn't just have speed incoming, but if we could get all of the stats coming in from this design data. I might want that to be a different sheet. This is going to get kind of clogged up if that's the case. Maybe I want to go the other way, actually. Maybe I want to flip this sheet so that it goes character name, then the stats. Like maybe I just want to flip axes. So each column is a different character and each row is a different stat. That might actually give us more room. Regardless, we still gotta get these stats importing more fully. So I'll leave this as in progress still. But we have our encounter manager. We have our team manager. We have refactored the loading of the characters to be based off this. So this is all done. Next time, probably try and finish this up. This would be kind of neat for kind of just finishing off this main task of like random encounters. I wouldn't mind fixing some of the weird death sequencing stuff, because that's going to prevent us from really testing what a battle feels like if enemies are popping up and if characters are popping up every time they die. So maybe it's just a bug fixing next time. Maybe it's just trying to get the combat to feel as non-buggy as possible in the next stream. I got time to think about it. It'll probably be another week or two before we get back to this. But continuing to make progress. Pretty happy with it. Good chunk of stuff. I think this did end up taking about 2 hours each. So that was kind of what I estimated it to. Yeah, this is probably going to be a couple streams. I think if we could resolve this, kind of any of the death problems right now, and then maybe look at importing stats next time, I think we'll be in a really good spot to start prototyping actual gameplay. There's some really neat stuff I want to try, but I don't want to talk about it until we can actually start building it. For now, though, this is going to be Tolhi signing out. Later, guys.